Hey everyone, hi. I'm Mudit. Very good morning, good evening, good afternoon to whichever part of the world you're joining from. Um, if I am live and you can see me, can you please drop a hi comment where you're joining from? So we are streaming live across various platforms. So it will help me to understand that yes, you can see me and you can hear us. We'll be starting off with the session very soon. Um, yeah, if you can hear me, just drop a hi comment so that we know that yes, things are very well in place and can get started. Hi Arjun, I can see comments from YouTube. Are people on LinkedIn able to see me as well? Just let me check. Yeah, we are live on LinkedIn and Teams. Yep. We are live on LinkedIn as well. This is perfect. Great then. So, hi everyone. I'm Modat. I'm one of the founding members of DeFi. I believe a lot of people who are joining this session are would be new to our ecosystem. This is what we have recently studied as per our stats. So, what we'll do is I'll probably give a quick intro of what we do as a community, as a platform, and we'll cover a brief intro for Supreet as well, because she'll be the one who will be leading the session today. So maybe we can wait for a minute or so since people are joining in. Hi Anjali, hi Abudur Rahman, hi Mandar. There's some LinkedIn users that I cannot see their name. I mean, but yeah, no problem. So I think I think let us get started. I'll talk about briefly about what we do, and then we'll also loop in Supreet. This is a 1 hour session, so the idea is that in this session we'll talk about the applications and then dive into the implementation part of things, so that like develop a holistic perspective around the problem statement that we are covering today. Okay. The goal for any live session that happens on DeFi is that there should be a jam-packed 1 hour learning opportunity, where you get a solid outcome out of it. The goal is that we'll try to cover some actionable insights in every single live session. So when you're joining in for the session, I'd urge that you stay till the end. You can start putting your questions beforehand though, because there's a team working on the back end. So if there are any questions that are coming up, we'll be happy to look at them and pick them when the Q&A time is up. Okay. I'll probably share my screen to give you a quick intro of DeFi. Supreet has also joined in the backend, but I'll probably briefly introduce, as shared, I'll briefly introduce DeFi to you so that, you know, for those who are unattended about it. So I'll probably give a quick intro. So yeah, I think you can see my screen, right? So today we are talking about this session where we'll be talking about predicting claims and building risk scorecards with AI. With us, we'll shortly, have Supreet Kaur as well, who's an assistant vice president at Morgan Stanley, and she's also the founder of Databuzz. Talking about DeFi, we are a global community of 100K plus AI enthusiasts, and we're on a mission to teach and build AI for the world. Whatever you see on DeFi, the resources, the courses, the boot camps, anything and everything is absolutely 100% free. We are supported by a bunch of organizations who help us in sustaining. A lot of learners also come forward and donate, which helps us in sustaining further and growing our impact. But as a learner, when you're coming on board, you can learn anything for free, including the certification courses and all. Um, Now, talking about what we are here for today is this particular session. Right after this, we'll also have another session with Alexi, who's a principal data scientist at OLX. This will be on the coming Wednesday after this session. Then this weekend, we have kicked off a particular 9 week data engineering boot camp, which will be covering the basics to the advanced level data engineering. So you'll be getting hands-on learning on as well. You'll be developing things, and you can ask questions on our Discord server, and people will be, willing to answer them. These are the instructors. Alexi, who will be with us in the next session, is the main instructor. Along with him, we have Sejal, who works with Center Berlin. We have Victoria, who works at DBD Labs as an architect, and we have Ankush, who is a staff developer at Shopify Berlin. We also have two another boot camps starting off very soon, and their registration ends on the coming week itself. So if you're someone who's looking to get started in data science, this is something that you must check out. I mean, the earlier the better. So this is a 4 weeks data science with Python boot camp. I mean, it'll cover your summer so that you get to learn data science and get started in your A journey in a very rock solid mode. It's by Analytics Club at IIT Bombay along with DeFi. Along with IT Bombay's Analytics Club, we also have another boot camp which is running, which will be closing in a week. In terms of registrations, that is around deep learning. So you can see everything in terms of syllabus and what's inside the boot camp at defi.tech. When you visit the website, you just have to go to the section, defi.tech/community. When you go to it, you have to go to boot camps, and there you can find both the boot camps which are upcoming, and the active boot camp is also visible there. Okay. The boot camp registration closes in a week, so that's the time till when you can log in and can get started. Okay. Now coming to the session, right? So with today we have Supreet, who has been kind enough to join us for the session and share her learnings with all of us. I'll briefly introduce her, and also she'll be with us on the call shortly. So she's currently an assistant vice president at Morgan Stanley. She's also, she manages various AI products there, takes takes ownership of end-to-end processes in terms of deployment, plus also the GTM strategies of those particular products. She's also the founder of Databuzz, which is an AI-driven, volunteer-driven community for AI enthusiasts, pretty much similar to DeFi. She's also the US analytics lead for women in AI, a mentor at Rutgers University, Columbia, and Weaver. So this is pretty rock solid profile that Supreet has, and above all of these things, she's an avid educator. She's an avid speaker. Speaks on various forums, and she's kind enough to be with us today. So I'll just loop her in just a moment. Yeah, so I'm adding her as well. Yeah, so Supreet is with us today. Hi, Supreet. How are you?
Hey, Mother, thank you for calling me. Hello, everyone. Thank you for joining us live. Hopefully, this will be a very meaningful session.
Yeah, I'm
And
pretty. Yeah, sorry. Go ahead. Yeah.
no, please go ahead.
I'm saying that I think the community has been pretty excited about this. We saw an overwhelming number of registrations for this particular session. So what I'll do is I'll probably go to the back end. You take the lead. Stage is all yours. I'll be there when the Q&A starts, and we'll be capturing the questions as well. Yeah.
Yeah, please. Thank you. Okay, awesome. So I think Mudit has already done a great job in introducing me. So I'm Supreet, everyone. Just to give you a little bit more about my background, I am originally from India, as you all can guess. But in 2017, I moved to US to pursue my master's. I actually did a dual degree called MBS in data science. I graduated in 2019, started working as a data science consultant, and for 3 years I was in the healthcare and pharma industry. I was working with ZS Associates prior to Morgan Stanley. And then, so I basically moved from a regulated industry to a highly regulated industry. It's just that a lot of all of these AI use cases are of interest to me. I study them, and in my data science career as a student, as an intern, or as a profession, I have got the opportunity to work on some of the very interesting um, use cases. So that is why this is one of the use cases that really interests me, and I wanted to share my learnings today with all of you. Can you guys hear me? Okay. Yeah. If you guys have any issue in audios or anything, please feel free to use the private chat option.
Yeah. By the way, people can hear you, so
Okay,
just
awesome.
letting you. Yeah, interacting on comments as well. Yeah.
Awesome. Okay, awesome. So, so as Mudit already mentioned, that we are here to talk about a very interesting topic, which is claims prediction. And this use case is for the automobile industry, but you don't have to limit yourself to it. This can be easily extended to other industries. The talk is actually based on one of the blogs that I published, I think around 2 weeks back on Medium. So this is kind of like an overview, my thoughts around that on the blog, but I would share the link after the session, and you all can refer to it so that you have something to go to post the session. Let's start by discussing this use case, why it's so important, So one of the major factor driving the profitability of any insurance.
Supreet, are you facing any issue in terms of sharing the screen?
I just got kicked out for some reason. I don't know why.
You just got a.
Yeah, yeah. It kicked me out.
Oh, okay, okay, okay. People can see you live, by the way. I mean, I can see you on the platform.
Oh, people can
Yes.
see me? Okay, I don't know. I can't see the screen right now, so it's just blank for me. But I
Oh, is it?
can continue. Yeah, let me enter. Okay, it says, okay, sorry
Yeah.
about that. Can people see me right now? Okay. Yeah, for some
Yeah,
reason.
I think there was some glitch on the platform. I think now it is sorted. Yeah.
Yeah, okay, awesome. Okay, I'm gonna continue. I'm just gonna start with the start of the session and not my intro.
Sure,
Uh,
sure, sure.
okay, so let's start by discussing, right, why this use case is so important, or why should we care, right? So one of the major factor deciding the profitability of an insurance industry is the number and the amount of claims. So if you are a car owner, right, you must have observed a direct correlation between your premium that is charged to you every cycle and the number of claims that you have filed. So in US, this is at least how the market operates, right? Like if you meet with an accident or an unfortunate event, your premium instantly rises in the next premium cycle. That's why people are very careful here, and you need to drive your car very carefully because your premium can shoot up to a significant percentage. Now, obviously, there is a difference between how the commercial and personal vehicle industry works, but at the end of the day, it's all about claims. So if the companies know in advance, right, like which policy is risky and or which vehicle or which policy is more probable to find a claim, and how many claims can this person or this vehicle file, basically they can devise a strategy. And I'm no expert in underwriting, but at least they can charge higher premium to mitigate the risk. So, leveraging AI to build these prediction models can provide better and more accurate results. So you all have heard, conversations on fairness and bias testing. So in case the customer feels, that he doesn't agree with the premium or, with whatever your AI model has given, the data scientist can actually help backtrack it and tell you the exact features that influence the decision or the exact risk drivers that influence the decision. So again, that is also another reason why AI is so important, because it will point you exactly to your decision making process. And you can do it by creating an explainable AI model with the help of your complex models or some of the models that I'm going to talk about in this talk. You'll know how easy it is to explain, um, maybe to the to the senior leadership, or maybe to your customers. So, before I jump to techniques, right, I would like to spend some time on how you can prepare the data. We all have heard that the job of a data scientist goes mostly in preparing the data. So, there are a few attributes that you would need to prepare your model. Some of these would include the policy details, such as the policy number, which would basically act like a unique identifier for your data set or like your primary key, your policy date, your policy tenure, and a few more attributes like the premium and loss information, some attributes at least about the vehicle, right? Like how old it is, was it a lease vehicle? Did you buy it? What was the model? What were the features? And then comes your response variable, or Y, which is the historical number of claims. And you can also include reason code, which is like, okay, why did the accident happen, if you have that information. Okay, so another source of data that might be helpful but may not be available easily, right, is the demographic information. So things like information on the driver, the area he or she lives in, income, and you might have to procure all of this through external data sources. Again, it depends on your country, it depends on the problem that you're dealing with. You might get that information, you might not get that information, because a lot of that is also sensitive information or called PII. So you just need to be careful, if you can get that information and how to handle it in a secure way. And then there could be a issue where it is a new customer, which means that it is a cold start problem and you don't really have any previous information about their historical claims. They might just have signed up with your company, or this is their first vehicle. You might have to rely on a few external data sources as well. Like in US we have Carfax data, so that basically has a lot of information about whatever vehicles or whatever any vehicle, if that person might have used, if that person bought it, if that person leased it. But again, right, this information is not easily available, so you might have to do a little bit more digging to get to that information. And then, once you have your data, it is the general guideline or my experience is to have at least 4 to 5 years of history, because such data sets tend to be really sparse. Like if you imagine why a sane mind wouldn't like to meet with an accident or a file claim every quarter, right? So such information might not, it might not be like, you have a very heavy data set. So you do need to put some techniques here to kind of deal with this kind of sparse data set. So once you have your data prepared, it's always a good exercise to do a data quality check. So you should test for outliers and see if there are any records that are bizarre. So it is always good to kind of remove those records, or kind of deal with them a little bit differently, right? You might want to scale or normalize your data on a particular scale, so that everything, is kind of, so that basically your model doesn't treat it like a special record. So doing that really helps. And so I would suggest that if you see a policy that has a higher amount of claims, and you would see that easily, right? You will perform some sort of EDA on your data and you would be easily able to detect those outliers. So at least for your first training cycle, set them aside. And but again, this cannot be a decision alone. It has to be a collaborative discussion with the business stakeholders to even define, what is an outlier in your case. Outlier can vary from your company to the type of insurance cases you're dealing with, whether you're dealing with a commercial vehicle, personal vehicle. There can be so many parameters, and the definition of outlier can vary even from one industry to another. So now to apply ML algorithm, just like any other model, you will divide your data into a training set, a test set. An additional step that I would recommend is sorry, an additional step that I would recommend is to tune your hyperparameters by separating out a holdout data. So that will really help you, in tweaking the hyperparameters for your respective algorithms. Okay, so now let's jump to the elephant in the room, which is the machine learning algorithms. Now, these are the two that I kind of found them very successful, with the data set that I was dealing with. Again, you can feel free to try other algorithms, right? There's no bar on that. But I am going to talk about only two for the purpose of this session, and the ones that I found to be more useful for this use case. So I'm a huge advocate, to start the process with vanilla models. So the first one would be decision tree. So I'm sure most of you have heard about a decision tree. Sorry. Um, So most of you must have heard about a decision tree for a classification model. But for my use case, I actually used it as a regression technique. But the fundamental idea remains the same, right? The fundamental idea is that we need to reduce the error at each split. So error metric that can be used is mean squared error, right? So you
Um,
keep split.
Supreet,
Yeah,
I'm sorry to
yeah.
interfere. Are you sharing a screen by chance?
No,
Okay,
no,
okay,
I'm
good.
not.
Good.
Yeah.
Do you want me to do that for you? Think.
If you want, you can share the screen for the blog if you want that.
Okay, okay. That will be a guided way for people to, maybe follow on in
Yeah, of
case.
course. Yeah, yeah, sure.
Just a moment. Yep. One second. Just a moment. Yep. So we got that from one of the community members. So I thought of, you know, uh,
Yeah,
chipping.
yeah, yeah. That is why, if you can actually share the link on the private chat as well,
Yeah.
Mudit, for the
So we'll
blog.
probably email them after the session,
Yeah.
the link
Okay.
itself. Yeah.
Sure.
So we'll email it to all the users who have registered. All the
Okay.
community
Okay.
members will be able to, see it. Yeah.
Okay. 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 So I'll continue with the decision tree. Okay. So I used it as a regression technique, but the fundamental idea remains the same. The error needs to be reduced at each step. Error metric that can be used is mean squared error, and you keep splitting until you find a point where your model cannot do any better. And that is why decision trees tend to overfit. So obviously you are supposed to control how much split you want, and obviously there's very thin line between your model underfitting, overfitting. So you have to be careful while building the decision tree and doing the hyperparameter tuning. So the average prediction value is the number of claims in our case, and though it is very easy to understand, another issue with this algorithm is that any small variation can lead to a completely different results, and some of these variations might just be sides of the same coin. They might not even be variations in real life. So do start with this method, but you cannot consider this as a ultimate source of truth. This can just be like your baseline predictions or something you can use to explain maybe your senior leadership as to how a regression tree works, right? And second is a bit advanced algorithm that takes decision tree on next level, which is gradient boosting model. Again, here we leverage gradient boosting regressor, and the idea is that multiple weak learners combine to form a strong learner, which I also feel is a strong, unique select proposition of this algorithm. And the loss function here is again mean squared error. And since this is more sophisticated than decision tree, it does give a better and more accurate performance. So a few important parameters to note here are learning rate, number of boosting stages to perform, etc. And the biggest advantage is that it is robust to overfitting. And why most of the data scientists, including me, might prefer GBM is that it provides variable importance. And again, going back to the explainable AI concept, in this age and era, where you have to justify all your outputs, it is very important to know which variable drove your decision. So once you create your model, and especially if you are leveraging some of the Python libraries, you can easily visualize the important parameters and explain it to the customer or the senior leadership. Okay, this is why you are this policy is more risky than the other. So both the models, can be assessed through MSE or mean squared error. But another interesting metric to use is you can measure the lift of the model. So lift can basically be calculated by taking the average of your predicted and actual values. That's another metric that a lot of industries prefer. So once you predict the claims, definitely that's very good information. You can bucket the claim that is most probable to have the highest count of claims as most risky, and you would be able to know the risk drivers of the most risky claims, and then the claim managers can basically take a calculated decision while deciding the premium and the interest rate for a new policy. So that is all by me. I would like to open up for questions now. And thank you, everyone, for being patient listeners and dealing with my heavy voice. So, yeah, I'm sorry. I was actually detected as COVID positive last night, but I didn't want to cancel this session. So I just decided to do it. So, thank you for bearing with me.
Oh, okay. I did not know this. I think,
Yeah, it
yeah.
was just last night, so I didn't, want to cancel it at last moment. It just got worse. So I'm just, yeah.
Oh, I don't know how to, thank you for this. Thank you.
Yeah, yeah,
I mean,
of
that's what we kind
course.
of feel, either even after, testing COVID positive.
Yeah.
Um, so there are a bunch of questions that people have put up.
Yeah,
So
sure.
we'll start picking them one by one.
Um,
So
so,
first, yeah,
Mudit, is it, can I see the questions? Is it through the comments?
yeah, it has most of the
Yeah,
questions.
okay.
So, there are a few questions that that people have sent, and it's
Okay.
on. I've received them over our internal communications tool, which is Flock. But yeah, so
Okay.
I'll nudge
That's
you
cool.
about them. But we can start picking from here itself. So probably this question. Yeah, okay, this is pretty long, so we'll just read it out. Uh, so Deepak asks, he has built a basic model once. He has a couple of questions. How will you come up with a threshold value to come up with prediction as in against the default zero point 0.5? And second, how will you remove overfitting?
Mm, so threshold value again, right? In most of the industry use cases that I have dealt with, threshold value, I am assuming that you're talking about the baseline predictions and how to basically improve those predictions. There are two ways of doing this, right? One is obviously, as I said, you can use build vanilla algorithms. Those might not be most accurate, but it'll give you at least a sense or a range that, okay, this is the range in which your predictions would lie. Other is experience, right? Data science is a very collaborative effort. It's not a data scientist working in Soleil's building models, preparing the data. Once you have your predictions, you do need to have extensive conversations with the stakeholders and the SMEs, and do need to show them your predictions. You do need to discuss your model results, and that is when exactly you'll be able to know how close or off you are from your predictions. And that is why it's also important to have an array of different models, right? Then once you get that SME layer, you'll be able to know, okay, which model is closest to what my business stakeholders are suggesting, and then you can use those predictions. This is kind of like a long way, but this is the correct way of doing things. um, I think the
Yeah.
next, sorry, yeah.
Yeah, yeah, sure, sure. Yeah. You're picking it, yeah, from Deepak himself. So, uh, he asked in the initial part of the talk, you mentioned about about hyperparameter and to train on whole data something. Okay, can you please explain that part again?
Yeah, of course. So this is basically so this is how, kind of like in my experience, I like, you don't have to do it by this way. People usually use their training data. So like if you're dividing your training and test into, let's say, 70% train, 30% test, or 60/40, whatever percentage you come up with, they usually do the hyperparameter tuning on the training data, right? So it's, I think obviously it varies data science per data science, but I feel that you should hold out 10 to 20% of your data as the holdout data and do the hyperparameter tuning on that. So there you'll be able to know, okay, which hyperparameters, what should be the value of my, let's say, alpha, beta, number of trees, etc., is giving me which accuracy, how much accuracy. And then you can tweak it. And there are a lot of techniques out there available. There is actually open source technology. You don't really have to code the hyperparameter tuning techniques. So you can easily do that. So it's just kind of setting aside a percentage of your data to test your hyperparameters.
Okay. Um, okay. I think yeah. Let's say somebody wants to use those open source tools or models. So are they available conveniently on the internet, or there are special places where they can find them? I mean, any recommendations on that?
So, if you are using Python or R, there are some really good libraries that are available with extensive documentation, right? So, even if you're starting out in your career and you don't really know, or you don't really are like a math wizard or anything, you don't need to be that, right? Scikit-learn, then there is libraries for GBM in R that you can go to read about them, and you'll be able to easily see also, like, what each of the parameters mean in your algorithm when you're coding it, what is the acceptable range, and you'll be able to play around. So definitely, I think in Python at least, scikit-learn is like my sklearn and scikit-learn is like my go-to. And for preparing your data, definitely leverage pandas and numpy libraries.
Okay. Thank you for sharing those resources. On the math part, right? A community member had emailed me asking this, so I thought I'll pick it. So she mentioned that you transitioned from a mathematics background to a proper data science background.
Yeah.
So, I mean, what would be your recommendation to someone who's on a similar path, looking to transition from math to, or maybe a non traditional engineering field to data science?
I wouldn't say it's not challenging. It's definitely a challenge, that you need to take up for yourself. Even when you walk into a class of a typical master's in data science, the profile that you see of the students is either they're engineers or they're working professionals, and you are like, okay, do I even belong here, right? So you will get those thoughts, very normal. But I think that during your master's, you do need to find good mentors, good professors who can actually help you carve your path. And that was also the goal why I started Databuzz, because during my masters I did feel, oh, there is no one of my path, right? Like, whom should I go to? And that is why in Databuzz I do provide one-on-one mentorship if you register, especially for people who want to pivot in this field and don't have those those resources or those mentors in their life. And I can obviously, I think that can be a talk topic in itself, as to what resources I did, what I did during my journey. So yeah, in case anyone's interested, feel free to have like a one-on-one with me. I'll be happy to help.
Yeah, and on this note, maybe people should go forward and about Database and also follow Supreet on LinkedIn and Medium. So that way you will
Thank
be
you.
able to, maybe connect with her in a better manner.
Yes. And I would
Yeah.
also like to add, right, on Medium, I also have articles as to how I kind of pursued my degree, why I chose data science, how I got my first internship and job. So you can read about my life there as well.
Oh, nice. By the way, this is the exact same. I mean, not 100% same, but one of the things that I personally related to when I was becoming a part of DeFi, that if somebody is new to data science, right, it's really tricky for them to find like-minded folks who can help them. Now,
Yeah,
if you are pretty much into the journey, it becomes definitely easier. Which is when later on we came up with more advanced courses. But when we had our first boot camp, the idea was just to bring along people who are just beginners and are willing to help each other. And I think yeah,
correct.
it's a great thing that you're doing at Databus, and people should
Thank
go
you.
go there and check it out for sure.
Yes,
Um,
please.
one question that a community member has put is, 1 second. So yeah, I think yeah. Or how can you remove false positive cases from from your model? Yeah, I mean from the result.
Um, so, I mean, there are techniques, conventional techniques out there as well. But personally, again, in my experience, I haven't really used any technique, right? Even though your data sets are huge, but once you are kind of able to bucket them, once you have the results, especially like in this use case, you'll get high risk, medium risk, low risk policies, right? It becomes very easy to analyze them, right? Like you can put them on a dashboard, you can put them, even in a PPT slide, because now you don't have a million records, or all the policies that you're assessing. You are assessing buckets. So then when you find that, oh, this case doesn't look nice to me, this doesn't go with the prediction, this, so a lot of, again, I said, a lot of gut work and a lot of collaboration. I don't think you can solve everything, with the help of techniques. So I'm a huge advocate for collaboration. So you'll be able to know that, but I don't think there is, like, kind of a direct way for you to do it. I would say when you're visualizing your data, even pre-modeling phase, when you know those, remove them. Even if they might not be false positives, just do remove them at first and deal with them later. But when you're building your first training, I would say, model, don't put them there. That's why I said, but again, a clear assessment of the data, like in big companies, at least, you also do have data quality checks. You do have, there are teams that do data quality checks, so they take care of this. But obviously, if you're a small organization, those tools might not be available for you. But definitely do check out resources where, how can you do those quick and dirty DQ checks by using visualization. That might be helpful to detect that pre and post modeling phase.
Okay, okay. Thanks for covering that. Also, a community member has shared a few resources. He says that circuit optimization, and probably this is on the lines of what you mentioned in terms of tools. He mentioned that circuit optimization, and then Shapely could be an
Another
important thing
one.
that people could.
Exactly. Yeah. I totally second that. I think, because there are not all the algorithms give you variable importance as direct as GBM does. So if GBM is not fitting your use case, you might want to opt for something else that'll give you, variable importance. So yeah.
Okay. One of the questions that a community member had asked is, how can we decide the metrics for the model? Because they probably, came across a blog and they had this particular question to ask. Uh, yeah. How do they decide the metrics for the model that you mentioned a few metrics along the talk as well? So how does someone decide that this is the metric that they should go with? Probably.
Do you mean like metric to assess the performance
Yes,
of the
correct. Yeah.
model?
Yeah.
Okay. So again, I think why I chose, lift or mean squared error. I think first of all, like, decision tree uses mean squared error, kind of as a default metric to basically reduce the error. So that was one reason, to use MSC to kind of assess the performance of a regression model. And the lift is, so again, I think it's a lot depends on the industry, right? Like a few industries do prefer lift as one of the metric to assess the performance of the model, but it will vary on your company and on your industry. Like some of the industries don't prefer lift; they just want to see accuracy metrics to kind of assess the performance of the model. So again, that is again something, you should have a discussion with a lot of your stakeholders to assess. But MSc is a standard one that you should definitely use, but the other one should be very business oriented, that can that can go with the other folks for whoever you're building the model.
Okay. Okay. A quick question on these lines is, what is lift?
Okay, so in simple terms, lift is basically that, okay, if I kind of built a prediction model, how much did my model help in improving uh, my predictions, right? So if I was not using a machine learning model, what were my predictions? Now if I'm using it, how much lift did it get, in simple terms? So, like, how you know the term lift, right? But yeah, the formula is also very easy. It's calculated by taking the average of your predicted and actual values. So yeah, it's a very
Okay.
easy formula as well. And in
Thanks.
this case, right, there are other ways of, okay, so just to kind of add there, right? So when you're calculating your lift, right, in terms of this particular use case, as I said, that once you do your predictions, you'll be able to kind of bucket your what do you call policies into high, low risk, based on the risk. You can actually calculate lift on each bucket separately, right, and visualize it just on a simple line chart, and you'll be able to see, okay, what was my lift right? So you'll be easily able to see that. Yeah.
Okay, okay. Thanks for mentioning that. And that's a pretty actionable uh, answer, I would say. One question that needs to be asked really quick. Could you provide an example of work experience on claims prediction or publications in peer-reviewed journals?
uh,
Yep, I'll put it across the link. Yeah.
yeah, an example, an example of work experience on claims prediction. um if I understand your question correctly, uh, I think this use case that I'm describing was actually, I did it in one of the during one of my, I would say, industries. I wouldn't like to, give a lot of details
Yeah.
out here,
Let the
but yeah,
name be X,
in
probably.
yeah, in one of my jobs, I would say. So I did this. So definitely, it was in one of my work experiences. Um, but okay, let me add, what I understand the question. So if you are asking, okay, what industry it fits in, yeah, definitely any insurance company, right? And any actually insurance and reinsurance companies, this is a perfect use case that it would fit in, right? So those industries, it would definitely fit. Even in the healthcare, healthcare industries that are dealing with insurance, this could be a very interesting use case even for them. So yeah, I think that should answer your question.
Thanks for giving a shot at answering this one. On this slide, I have an absolutely naive question. What is reinsurance? I have no clue about it. I think a lot of people might
uh,
also. Hmm.
Yeah, sure, of course. So there is, there are some people kind of, who opt for an insurance over their existing insurance. So there's
Okay.
like a reinsurance industry which works a little differently from the insurance industry. So yeah,
Okay. And their prediction models also work in a similar manner because in those cases, there will be an existing data available, right? Unlike
exactly.
this case.
Similar to that. Yes, similar to that. Yep.
Okay. Okay. One question that Sonia has asked is, can you provide good techniques or open source tools for feature engineering?
Yeah, as I said, right, like, when once you kind of explore sklearn, scikit-learn, with GBM, right, like that's kind of a functionality that comes in. I think one of the functionality was also mentioned by Makarant, if I'm pronouncing your name correctly, right, on some of the techniques. But feature engineering, I would also say, can be done using a lot of EDA as well, right? Like once you have your model in place, a lot of companies these days are building an explainable AI model on it, even if it's a neural net model, right? Like they are building an explainable AI model because you need to justify your decision making. That is also when you build, like, use all of those techniques, and some of the techniques for explainable AI are, there is lime, and then there are a lot of techniques that I don't remember on top of my head, but definitely there are good resources that you can refer to. And even decision trees, actually one of the explainable AI techniques, right? So once you're able to visualize it, you'll be able to address, okay, what are the most important features that are driving my decision. But yeah, for open source, I would definitely say sklearn, scikit-learn, all of these traditional Python libraries should give you the results.
Okay. Okay. By the way, a kind of a shameless plug here. We do have boot camps and courses around explainable AI also. So if you want to learn,
Yes.
yeah, you can go and access the resources for free, both on the courses and the boot camp section. We don't have an ongoing boot camp on explainable AI, but it'll be there soon.
Oh,
So yeah,
nice.
just wrapped up a cohort recently. I
Wow.
want to pick this particular question, which is by Sonia again. In corporates, reinforcement learning is a big challenge. Did you deal with any use case? And how did you approach it?
Not yet. We are going in that direction, but I personally haven't done it yet. So I don't think I'll be able to answer this.
Okay, we'll probably pick one or two questions more. Wouldn't stretch it long for anyway. You have been kind enough to be there even after COVID test, positive test case. So this is a slightly lengthy question in terms of the text, but yeah, where would this model fit in? Will it help us answer if we should extend the insurance to a customer or reject the claim from existing customers? In second case, in terms of rejecting, do we take claim amount as model feature?
um, I'm not sure. Okay, I'll start from the last question. I'm not sure if you'll get the past claim amount as if that information will be easily available to you. Again, that's sensitive data, so I'm not sure if it'll be available. A lot of premium information will be available to you, premium amount that can be taken, right? Like if you see an increase, this means definitely a claim was filed or something happened. So yeah, you can consider that as one of the important variables. Rather, that will act as one of the important variables, I can tell you beforehand. um, and then, will it help us answer if we should extend the insurance to a customer? Extend the insurance? Yes, definitely, right? Like if you feel that, okay, this customer has like, is on the highest risky bucket, and that too from the past few years. And that's why I recommend it, right? Take 4 to 5 years of history, right? It might be a new driver, and then, they might have improved their driving skills. So you do want to give them some benefit of doubt in that case. If you see that, yeah, bizarre history in the past 4 5 years, and then you would definitely like to reject the claim of that person or charge them with insane amount of premium, so that companies are safe. And they do that all the time, right? Like they do that. So yeah, I think definitely it'll help you. And where would this model fit in? So I think your question is around the models that I've described. Where would they fit in, if I understand your question correctly? I think one of the use cases that we are discussing, obviously prediction claims. And as I said, that you don't have to limit yourself to this industry. Anywhere where any kind of prediction is involved, and which involves a lot of risky prediction, because claims are risky, right? Like a lot of money goes in covering for these claims. This use case and these algorithms would definitely fit in.
Okay. Yeah, there are okay. So there are questions for
Let's
as
keep
as you
going.
said, we're wrapping up with questions. I think people have started
Yeah,
asking them. Yeah,
sure, sure, sure.
this is a quick question. Are you a cloud advocate, and do you use any cloud native tools for your ML tasks?
Oh, definitely, definitely. I think a lot of these use cases that I talk about, they wouldn't be possible if you didn't have cloud technologies. And these days, with the advent of ML ops, which is kind of a combination of DevOps and machine learning, um, I think most of the companies are leveraging cloud tools to basically build your deployment pipelines, right? Like how do you build the model and put it in production if you don't have cloud technologies? And some of these are actually things that you need on a daily basis, right? Like with the live data. So yes, definitely leveraging cloud technologies is very helpful. I personally kind of have worked or know about AWS, Azure, and they do provide you a lot of those tools that can help you do the automation with little to no knowledge of coding. So definitely you should check out those resources.
Yeah. I mean, the ongoing data engineering bootcamp also has a few of them around GCP, though. That's Google Cloud. But yeah.
Yeah. Awesome.
Uh, so the last two questions, okay, we'll probably wrap up after this. It's Deepak has asked any tips or tricks you have picked in building claims prediction by experience that is not available in internet or books, and any resources you recommend on A/B testing for insurance.
Um, I think before I did not work on this use case, I didn't know that decision trees in GBM can actually be very helpful as a regression problem instead of a classification problem, because in most of the books you read them as a classical classification models. So that was my biggest learning. And if you see till date on internet, you wouldn't find extensive resources on GBM as a regressor or decision tree as a regression model. Most of the resources are available around classification, and that was also kind of my motivation to write this blog, to kind of know people that this is also one of the use cases that does exist here. Any resources I recommend on A/B testing for insurance? I am no expert in the in the insurance industry, but generally for A/B testing, because I feel A/B testing can be done on any industry. I mean, you don't have to limit yourself to insurance, but if you are in the insurance sector, I would recommend reading A/B testing and applying A/B testing. One course, if you are asking, that has kind of helped me understand A/B testing is the one on Audacity, especially if you are kind of getting introduced to A/B testing. I'm not sure if DeFi has something. I don't want to do cannibalization
We've
of your
done a
products.
yeah, yeah, there are on-demand resources for it, but yeah, no,
Awesome.
that's
So
absolutely fine. People can learn anywhere they want to. We're just
yes,
free
but
and
that is like one of the resources that I used to work on A/B testing. So yeah.
Okay, okay. No, that is helpful when you're, citing the resource also. That is really helpful, even if it's not on the helpful community. So that's fine. One last question. I think it says LinkedIn user, but yeah, that's how I am seeing it. Are neural networks used in this area, and are they explainable? And also, since
Definitely.
we've talked about explainable a bunch of times, I believe not a lot of people would know about it. You could probably briefly introduce that and then talk about this.
Yeah, sure. So explainable AI, right? Like it's kind of a concept which was coined, I think, a few years back now. It is basically, it serves the purpose. It serves the biggest purpose. One is for a lot of senior leadership, all the your advanced machine learning models are a black box, right? How do you kind of unbox that? How do you develop the trust of a senior leadership and tell them that whatever predictions that you have made are accurate? Because here we are talking about profit and loss of billions of dollars, right? It's a big thing, and you need to be careful, right? Like, and how do you justify that? So that is where explainable AI comes in. So you basically develop your advanced models, and that can be through neural networks, definitely reinforcement learning, whatever fancy model you would like to use. But you also build like a layer of simplistic model on top of it, right? A few of them, as I said, decision trees is one of the popular explainable AI model that is used, and that is why also I bought it here. And as I said, that there are some like, it's called Lime. And there are other models, right? Again, it will depend on your use case, but decision trees is one of the most popular that I have used in my career. So you should definitely check those out. And our neural networks used in this area, definitely you can use neural networks, for your prediction purposes. Personally, I didn't use it here. I did use some simple methods, and GBM was the most advanced that kind of fit in that arena, fit with the other stakeholders. But yeah, obviously, feel free to use it if you have that data. Yeah, definitely.
Oops. Okay. Sorry. Yeah.
Yeah,
Okay. Cool. I think we're done with our questions, and there's something that I definitely want to show that a lot of people have put across is, the words of thanks. Folks have been thanking,
thank
and
you.
uh, I think, yeah, I'm out of words in terms of how we can thank you for this. I had absolutely no clue about, the COVID part of things, and thank you so much
No,
for
of
being with us today.
course. Yeah,
Really,
and
really.
please, if I was not able to answer your question or something like that, or now, you can actually register through the database button. There is a Calendly link, and you can use that to book a session with me. And I can, answer your questions if you want to discuss your use case, or if you want to get a one-on-one mentorship. Feel free to reach out to me through that. And definitely check out my LinkedIn. There are a lot of other interesting resources out there. And thank you everyone for being here.
Yeah, thank you so much from the community's behalf. I'll talk about one thing very briefly though, since we spoke about a few of them. These are a couple of sessions which are coming up. It's on the lines of what we have discussed, a bunch of things. So the first of them is around data engineering, which is machine learning on streaming data. Second is around recommender systems, which is an ML algorithm. It's more on the implementation side of things. ML ops. This is again how you talk about taking ML models to production and then using them when they're live. The next one is around gradient boosted decision trees in classification regression models. This is something that we discussed several times today. In this particular session, we'll be going in a bit more depth. We took an overview across the insurance sector in this particular session. This will be on a different agenda. And the last session that we have published now, we'll be coming up with a lot more. This is around data visualization using Plotly. It's an open source tool based on Python. So yeah, we'll be talking about in relation to Dash and analytic web apps in Python. This is what is lined up. And yeah, thank you so much. Thank you everyone. Thanks a ton, Supreet, for being with us today. Really appreciate it.
Yeah, of course. Thank you for inviting me, and hopefully we can have a lot of these interesting sessions after my recovery. So yeah,
Yeah, definitely. We'll also be glad to collaborate with Databuzz. We proactively partner with communities like yours who are doing awesome work. So yeah,
definitely. Let's make it
we'll,
work.
yeah.
Awesome.